very first 3D printed parts in a production vehicle in January. And then setting stage, these are the first PPAP'd with one of our CMs with a tier provider.
What's a CM?
A contract manufacturer.
Okay.
And this is a connector cap for a truck platform. And so if you're getting the towing package, you don't get the towing package, just protects the connector and gets stowed away in the vehicle. So I had to pass all the U.S. car approval, gravel testing, and all the tough aspects. And it's 15,000, 16,000 of those now on trucks.
Man.
How do you produce that many 3D printed?
So
Okay,
Should
this
we
is
wait
too
for the
good.
show?
Save it
Yeah,
for the
wait
show.
for the show.
Because if
Yeah, we're going to start the show.
That's a good one.
This is like, well, what are we going to talk about?
As I told you.
a million of these
Yeah.
this year, dental running shoes. So it's building off consumer that's scaling. Yeah.
So you said you're from North Carolina. How did you end up in
I
California?
was on the faculty at University of North Carolina at Chapel Hill for 25 years. Started several companies as a faculty member, and we had this invention, decided to leave the academy after 25 years, and the investors asked me to lead the company. I'm a polymer guy, and so my wife and I were just turning 50 and high school sweethearts, and decided to move to California.
Wow. Do you like it better than California? Or?
So, well, being a faculty member is a nice, easy, relaxing job.
Well, I mean, North Carolina is a
where
wonderful
everybody respects
state.
you.
Yeah.
Look, when I walk into the parking lot at the company, all I see are car payments and mortgage payments and, people counting on us. And, that puts a pit in your stomach. You don't have anything close to that as a faculty member.
Right.
So that kind of responsibility as a CEO is tough. It's just, but, we've got 500 employees. We've raised $680 million. And, we've got Alan Mullally in our board and Ellen Coleman from DuPont. So it's amazing. If you're a polymer guy, it doesn't get any better than this. Because we're now going digital, mold-free. Really enables designs that are unmoldable. So it's fun. It's amazing.
Yeah.
Do you like living where you live now?
It's expensive, and it's intense.
Where do you live?
I live in a little town called Los Gatos.
Oh, yeah.
Okay, yeah.
In the foothills of Santa Cruz Mountains,
Right.
and our company's in Redwood City, and so I'm passing Google, Facebook, and Apple on my way to work. So get through there early, but it's a lot of traffic. But the Tesla allows you to get in the HOV lane,
Yeah.
and that saves me an hour a day.
So what
Drives
was
a lot of sales.
So what was your commute?
Of
What
it.
was your commute in North Carolina?
7 minutes to 30 in the morning to an hour and 15 at night. Yeah, so there's trade-offs.
Yeah.
Yeah.
But look, we have 60 ex-Tesla employees at Carbon,
No kidding.
and including the founding vice president of engineering at Tesla is our founding VP of engineering. And just like the Tesla car is still the only car that gets over-the-air software upgrades, it's a device like an iPhone.
Right.
Our printer was designed with the same DNA, and it's been 100% smart hardware, electrified, connected through our service
That
at
is so
AWS.
cool.
Traceable parts with data. And we do over-the-air software upgrades. Printers are getting better and better. And it's the first subscription model ever for a piece of manufacturing hardware. So instead of CapEx in a factory, it's OpEx. And never, Alan says, future-proof from obsolescence. That's sort of the framework.
We're going to get going in just 6 seconds here. I'm going to introduce them, then you, and throw out the first question, devote the first half of the show to you.
Thank you.
Watch Autoline After Hours live at Autoline.tv every Thursday at 3 p.m. Eastern Time. That's 12 p.m. Pacific. You can subscribe to this podcast for free by searching for Autoline in iTunes, Stitcher, or YouTube.
Autoline After Hours is brought to you by Bridgestone Tires, your journey, our passion. Lear, a global leader in automotive seating and electrical systems. Borg Warner, propulsion solutions that support a clean, energy-efficient world. And by DIA MTS, for advanced manufacturing machinery and lightweight components.
All right, everybody, welcome to Autoline After Hours. Especially you, Gary.
How you doing, John?
I'm doing pretty good.
We were at the Hyundai Technical Center this morning. We'll get to that a little later on in the show. But
Right.
driving back to the studio today, I saw a Murano Cross Cabriolet and a Honda Cross Tour. Talk about seeing two unicorns out in the wild. I mean, it's like, geez, what are the odds?
What are the odds, really? Hey, we've got Jeff Gilbert here from WWJ News Radio 950.
Didn't see any unicorns today. Maybe a dinosaur or two, but that was about it.
All right. But we got to introduce our special guest. He's Dr. Joseph DeSimone from a company called Carbon into 3D printing. And Joe, got to tell you, thanks so much for coming on the show.
Oh, it's our honor. Thank you.
I learned about your company a little bit earlier this year. You were out visiting Detroit. We met, and I thought, we got to get this guy on After Hours. So, and let me tell the audience, too, we're going to be talking about 3D printing for the first half of the show. We've got Mike O'Brien from Hyundai coming on for the second half. But if you got questions, especially about 3D printing, you got to get them in here. You can send us an email, send it to viewermail@autoline.tv, or you can give a call, and that number on the screen now, 620-288-6546. And we'll be watching for your questions as they come in. But, Joe, let me kick it off by saying 3D printing. I mean, I remember when they used to call it stereolithography or rapid prototyping. But Carbon, your company, is approaching it very differently. Without spending the whole show on exactly how, give us the thumbnail of how you've approached 3D printing differently than anyone else.
So 3D printing, to your point, has been around for 25 or 30 years. And it came out of a mechanical engineering culture where I think it's actually a misnomer. It's sort of like 2D printing over and over and over again. And you know, our team of chemists and physicists, we came at this from a very different approach.
You're a polymers guy.
I'm a polymer guy. I'm a chemist.
So you're not a machine tool or manufacturing guy.
No, I'm learning a lot in that space.
Yeah.
But basically, chemists grow crystals, right? We grow things. And so we took an approach where we use light and oxygen to grow parts. And we grow them 25 to 100 to 1,000 times faster than traditional 3D printing. And this gives you the power of light. I think of light as our chisel. So we can make really complex objects very quickly. That was the first breakthrough. The second breakthrough was, how do you get a real part out of a light-based printer? Because most people think of 3D printing, you think of trinkets, you think of brittle plastics. We had a breakthrough where we combined what we call dual reactive resins. Think about epoxy. Two liquids come together, a great material. No one ever went down that kind of path because the printers were too slow. Because we were going really, really fast. We knew we can get into reactive liquids. We also made them UV curable. And so now we have over 50 different resins that have the properties to be a final part in a whole host of applications that you can make digitally without molds.
So is printing the appropriate term for you guys, or is it more additive manufacturing?
So, people use both depending on what you think about. It's clearly an additive process. Some people think of it as light fusion or light extrusion as what we do. Every microchip, every computer chip is all made with patterned light. Powered Moore's law for the last 50 years, but that's patterned light in 2 dimensions. And we use pattern light in 3 dimensions to grow our parts.
And this is just normal light? I mean, there are other processes that use lasers in a vat of polymer, and they're just...
Yeah. This is a DLP projection system. We have cooled optics, cooled electronics. We get more light out of LEDs than anyone on the planet does. Amazing optical system. We use oxygen and light to grow parts. And it sort of looks like Terminator, where you actually have a part growing out of a puddle. And that's sort of the...
Here we got a clip of it running on the screen right now.
Yeah, so oxygen's coming through. Underneath that reservoir of liquid is a very special window that is not only optically transparent, but it's permeable to oxygen. And the oxygen prevents it from sticking to the window, but it allows the parts to grow off the window like Terminator.
Was it growing that fast?
No, that was an accelerated video.
Okay.
But when it comes to speed, I mean, my radio guy's understanding of 3D printing, which is like super duper shallow, is it's great to produce complex things, but it produces them slowly. But you're producing, and you're holding something up right now, things at manufacturing type scale. How do you make that leap to make that many products that fast for an industry like auto, fashion, things of that nature?
Yeah, great question. So we're printing 25 to 100 to 1,000 times faster than traditional 3D printers. So all of a sudden now we're in a realm where that matters. So for example, when we first started doing Adidas running shoes, these midsoles like I'm wearing, like this one here, we were first printing these it took just 90 minutes. Then it went to 45 minutes. Now it's under 30 minutes, and we have line of sight to 16 minutes. And these are breakthroughs where, like 60 printers could make 1 million pair of these a year.
And explain that, because even though you're saying you started out at 90 minutes with just the sole of the shoe, you're printing multiple soles at the same time.
So what happens is, through innovations in material science and innovations with our printing process to begin with, we have been able to optimize the printing process. And that's what over-the-air software upgrades gives us. Our process is fundamentally a software-controlled chemical reaction to grow parts. And so our printer is the first piece of manufacturing hardware ever to go out via subscription model. And with that, you get the over-the-air software upgrades. And so it allows improvements in the process. So through improvements in materials, it allows us to pull these faster out of the broth and to increase the accuracy and controlling the heat. That allows us to go faster and faster and make a finished part.
Joe, that sole, you're a polymer guy. Would you be able to make that with any other process? I mean, for those who are not seeing this, I mean, it's a very complicated honeycomb, and
It's a lattice work.
And I mean, it's just an amazing object, and
It's stunning. Lattices have been around. Mechanical engineers have been talking about the benefit of lattices for a long time. Lattices, historically, you could only make things where every strut was its own part. Think about bridges and buildings. Now, all of a sudden, you got materials like this. This is now a part for a football helmet for Riddell. So Riddell,
NFL football helmet.
American football, NFL helmet. We have over 600 athletes in the NFL and D1 schools now wearing precision helmets made by Riddell where their head is scanned. They're personalized products that are scanning. Think about a factory where you have to track an N of 1. Right, we do this. And so these lattices now, you can design geometries that can dissipate energy or return energy, stiff or soft. And so by combining geometry and advances in materials, you can now start making geometries that are unmoldable out of materials that have a wide range of properties. So we have a bicycle seat here from Specialized. Again, 14,000 struts. Tuned properties to energy return, allows blood flow and comfort. And so we've been running hard in the consumer products industry. We've also been running hard in the dental products. And I don't think you've had dentures on this table ever before.
Never on the show.
Never on a show. Maybe after the show, who knows? But these are the dentures that we have. And making dentures hasn't changed in 120 years. This is now all digital scanning, precision manufacturing, scaling precision products, and we've got big partnerships with companies like Affordable Care, Affordable Dentures, and approaching 10,000 people that are now wearing the first FDA-approved 3D printed dentures.
And, that's a complicated process to get dentures. They got to be fitted, they got to, it takes, weeks to get it done, and you guys can nail it exactly, precisely the first time.
Is that all one piece?
So these are printed as 2 separate pieces.
Okay.
Typically, to your point, 8 chairside visits to get fitted for dentures the old way. And then if you lose your dentures, you're back in a chair 8 more times. So with a digital approach, you can order a 4-pack, right? And you can have one one in your car. I mean, all sorts of convenience things. You're upselling people. So the point is, we're firm believers that technology can allow a decrease in cost and allow healthcare costs to lower. And so we've been feeding our technology into the consumer products industry, Riddell helmets, Adidas running shoes, Specialized bike seats, driving heavily into dental now. And as you know, the standards and rigor of the automotive industry is really robust. And we've been working closely with the Ford Motor Company. And in January of this year, we have the first ever 3D printed parts on production vehicles out of Detroit.
And explain what those parts are.
So this is our epoxy material. Again, it's all about materials. So this is like, you think about 2-component epoxy. We have an epoxy that's also partially UV curable. So it allows you to make amazing complicated shapes. So has taken our material, and they actually, Alan Mullally's on our board of directors, and they were among the first.
And I just need to interject here. Since he left the Ford Motor Company as CEO, my understanding, he's only joined 2 other boards.
That's correct.
One of them's Google.
Yep.
The other one's you guys.
That's right.
How'd you get him?
Well, Alan is a gem, and one of our board members knew him and made an introduction. And the thing about Alan is He pioneered digital fabrication when he was at Boeing. He was CEO of Boeing Commercial Aircraft Division. He committed the 777 to a fully digital manufacturing before anybody. He's a pioneer, and he wanted to drive that. So we've been doing. He says we do what he's been dreaming at forever. And then you all know how hard it is to bring new products forward in the automotive industry. We can bring parts forward in much shorter times. We can decrease weight and make geometries that are unmakeable. And it took Ford 2.5 years to get these parts approved, but we now have the very first 3D printed parts ever.
And I cut you off. What are the parts?
So this is an electric brake line bracket that supports it in the Ford GT 500. And so these are on the production vehicles now. And so it was designed to ergonomically, so it went through all their studies to allow people to assemble the car more effectively. So that's this part. We have a deletion plug for part of the F-150 Raptor truck in the Chinese market. They needed a plug in the dashboard, and that's what this is. And then this is a replacement part on the Ford Focus, 2006 Ford Focus. So replacement parts where the tooling's gone.
So where's the growth in the automotive?
The growth is around, once you have materials that the industry's comfortable with, then you take the digital design and it's a clean sheet of paper. So for example, this now is a connector cap for a major OEM that's already in the marketplace. It's gone through the entire PPAP process.
And explain what PPAP is.
So this goes through the process where approval process. It goes through all the rigorous testing, U.S. car testing. This is part of a towing package to protect the connector for a truck. And it had to go through all the gravel and dirt. And when you don't get the towing package, this connector gets stowed in the vehicle. And it's sitting there latent unless you want to get the towing package later. So we have 16,000 of these annually on trucks. And where this is going, but this could be injection molded. Mm-hmm. But this saved the program. This went to 20 weeks to get this approved, right? Imagine the tooling cost that you'd have to go through. So we rescued the program by being able to make something that was even injection moldable, but now you can make digitally and very quickly and go through the approval process. So where this is taking us is to this very exciting point where we now are our customers are making electrical connectors. So this is an array of 16 electrical connectors. And this kind of program is going through the formal process for approval, right? It's not out yet, but it's now got geometries that allow an optical, allows a data port to come into an electrical connector. And it's got designs that make this a much better connector, and it's now evolved to be an unmoldable connector. These designs now take twice the retraction force to disconnect the connector. And as you know, a huge number of 90% of the warranty issues in cars today are electrical.
And most of them are connectors.
And 90% of those are due to failed connectors. So these are a new wave of products, because these are getting into designs that are unmoldable and they're also more serviceable. So the holes in the center for removing the leads for serviceability, these now allow designs to make it much more serviceable, much more easy to assemble, and have better durability in a marketplace. And we think it's new waves of growth once you're able to have finished parts coming out of printer. And we're now cost effective with these systems where you're making tens of thousands, hundreds of thousands. It really opens up a whole new marketplace.
Because you can print 16 at the exact same time.
We're approaching 1,000 printers in the field in 14 countries. And you aggregate 100 printers, you're printing these, and if they're printed in 45 minutes or less, it's an enormous throughput in a factory.
Joe, let me ask you, you raise an interesting point when you talk about parts that are unmoldable and that you have a very interesting, elaborate design here. So it seems to me that, industry's full of designers who know how to design in the traditional way, and there's a whole bunch of manufacturing engineers who know about injection molding and know about metal cutting and so on, but don't know about your processes. How do you get the industry to embrace this technology?
You sound a little bit like Alan Mullally. And in the very beginning, that was, I think, in my interview process with him in the due diligence. His very quick take is, how do you quickly get 100,000 engineers trained to think new differently, right? That's the step. So this is that we understand this is a bit of a grind. It's more about education and retrenching, but it's a complement to injection molding, right? And so a lot of our customers are injection molding. There's 4,000 injection molding businesses in North America. They're setting up a digital complement to their analog molding business. So it's all about training. So we do a lot of lunch and learns, and we got a lot of educational materials helping people see that. But it's getting started. It often starts with 1 or 2 printers, go through the design process, go through training, and getting the very first parts going. We do deconstruction of existing parts, help people redesign them. But you really win when you get to designs that are unmoldable. What's also cool is this new material here. This is now replaced. This is our EPX82, an epoxy system. This replaces 30% glass-filled PBT. And it is lighter, right? So you think on an average car, on these new electrification vehicles, there's 29 pounds of connectors in that car, right? This material is 20 to 25% lighter. We're saving 6 pounds.
Just in connectors.
Just in connectors, to eliminate the dense glass. And so it's this tailwind of things, everything's going electric. Autonomous vehicles are coming. The design times are getting shorter and shorter. And so we're really a lot of times design changes late in the process, and it's a challenge. And if you can't get molding tools, this high cavity electrical connector, the tool would be well over $500,000. You don't know if the design works. You can do all the FEA analysis you want, simulations, but you don't have the part. Now you get the part the next day. You go through a process, and what happens is every time you have a new part, it's another increment of innovation. And if you're doing injection molding, and every design is strung out by 6, 12 months, you're slowing down innovation, right? This, we think, is a dramatic acceleration of the innovation process. Will drive new waves of growth, new product designs, but it's all around materials made digitally. And the last thing I'll mention is traceability. You can just look at the Ford part. It's got all the data on it. And the midsole for Adidas has got this data matrix on that. And so this is machine readable. So every part I think of as alive. Every part has a unique record in the cloud. When the part is born, its birth certificate's there. We have which data file, which lot of resin, which printer, every photon that goes into it. And then there's post-market surveillance. In the serviceability, you can look at the connector, scan it, and it will repopulate the record for that part. So there's a lifetime of post-market surveillance that's going to be increasingly important with traceable parts.
What part of your business is automotive now, and where do you see that growing to? What's the goal? Because you're in a lot of different areas.
Yeah, half our business is in consumer, 25% is in dental. We've been systematically, methodically building out use cases in automotive and other industrials because it takes longer. We had to get the materials go through the gauntlet, the appropriate gauntlet there, and we finally have it now. So now I'm in Michigan once a month now, so it's really taken off.
Joe, if John was mentioning stereolithography earlier, and I mean there are a multitude of processes from various companies that are all in this space now. I mean, we go to a maker fair and there's a guy basically building something with fishing wire, basically. I mean, are there horses for courses? Are there applications that you guys are more well suited for than some other process?
Totally. I mean, 3D printing's been around for a long time. It's been an $8 billion prototyping market, right, for the most part. And half of it's metals, half of it's polymers, and $8 billion includes the printers, the materials, and even the parts, and the software. Injection molding's a $300 billion marketplace. We at Carbon have uniquely cracked the code on how to take polymeric parts digitally into manufacturing. And this new category that we're creating is all around what are the use cases that are actually scaling into production. And we've shown it with Adidas, we've shown it with Riddell, Specialized. We now are moving, we certainly have shown it in dental and now moving into automotive. So I think the difference is this design SLA where you had trinkets and brittle plastics that were good for prototyping. Now you're digitally making finished goods. You're designing parts on the means of production with the same materials that you're scaling up. You know, traditionally you design a part with your favorite software tools. Then you go to a prototyping technology, the legacy 3D printing. It's not the printer, it's not the manufacturing tool, it's not the same material. And you do all that because you've got to design the tool. And you want to make sure the tool's right, because it's a 6 to 12 month investment, $500,000 sometimes. And you do that before you scale, and that's what takes, you know, a year, year and a half. Now that you can design on the means of production, we are disintermediating the product development cycle. We're cutting out prototyping, we're cutting out tooling. We can make things directly and design parts directly, and that's a whole new world.
Hey, we've got some questions coming in from the audience here. Free Spirit 1, wondering, you ever go into metal?
No, we do
You're
polymers.
a polymer guy.
We stick to our knitting here, and it's polymers. I wish we could do metal. Somebody needs to have a breakthrough in metals like we've had in polymers, but I don't see it.
Okay, OG Jawdins says, what about making a huge printer that can make parts that are 15 by 15 feet?
Yeah, so what's interesting, it's all, you know, being a startup, you know, it's all about product market fit, and we have 2 printers now, basically. The big printer is 5 times the build area as the other printer. 40% of the plastic parts on an average car fit within the build volume of the small printer. 60% fit within the build volume of the large printer. And so we've got designs for bigger printers, but, you know, we got a lot to do. A lot of these complicated devices can fit on the existing printers.
Do you think the future for your process is in componentry rather than, I mean, you know, everybody's talking about the 3D printed car, you know, I mean, and
Yeah, I do. I think it's all about the components, high value, high performance components for the next 3 decades. And the idea, look, you know, the idea of making a whole car, you know, it's exciting, it's interesting. This is where scale happens, and this is where performance is enabled, and that's where we're playing.
Does electrification, specifically pure EVs, does that create other opportunities for you? Because a lot of the components that'll be on some of those vehicles, some of the future ones, may not even be being made today?
It's where some of the biggest opportunities for us, going to high voltages, the electrification, the autonomous vehicles, and I think later you'll hear about fuel cell vehicles. Anybody that's starting out with these types of vehicles where you're doing a design change, we're trying to catch those big waves. And so those are big tailwinds for us, as well as, remember in BMW, they used to have just the 3 Series and the 7 Series, and now there's like 30 platforms. So but the same number of cars, that's a tailwind that drives what it is we do. And then the last thing I would say is the potential for lightweighting materials with lattices and avoiding glass, but also recycling. You know, what's really cool is that not this resin, but the resin after for Adidas, we're going to be able to recycle those, you know, single-use plastics. And I think, you know, the car industry uses over 200 different materials in their vehicle. You don't have a hope to recycle that. I think a car can be made out of 8 polymers. And once you have that kind of mandate, the opportunity for having true cradle to grave and back again really opens up.
so you would be able to recycle that material and use it again to make
right.
another sole?
We're going to roll this out in the dental models next year, where after the model is made, for making Invisalign-like products for other people. Those models will come back. We're going to turn that back to liquid, and opens up new products after that.
Wow, so true sustainability.
Cradle to grave and back again. Look, we're passionate. This is going to be big. If we don't pay attention to this now, no one will, and we got to do it out of the gates.
Hey, we got another question here from Whipgood. He wants to know, what about 3D printing for the aftermarket, and would that bring replacement prices down?
In fact, that's what Ford launched. So Ford launched 3 parts. 2 are for production vehicles, and this part was for a 2006 Ford Focus. So replacement, and then aftermarket, I'm glad he brought that up.
Yeah.
This is a BMW part for the Mini Cooper. And so people are getting to name their vehicles. So you have a really cool app. You go in, you can design the parts for yourself, and it's printed on our technology, and it opens up the ability for personalized vehicles.
Hey, you touched on it, but I'd like to go into a little bit more detail quickly. We're getting down towards the end here. Your business model is fascinating. people or companies don't buy your machines. You lease, let them subscribe to them, and then you can update them with over-the-air updates. So fill in a little bit of the details on that, would you?
Alan Mulally pioneered this when he was at Boeing. As the lead engineer on the 777, he wanted his supplier, GE, to no longer sell him jet engines. He wanted power by the hour. He wanted to build airplanes. He wanted to let GE design the best, most fuel-efficient jet engines. So the OEM drove the supplier in that direction. We came at this, and our founding vice president of engineering, Craig Carlson, amazing icon in Silicon Valley, was a founding VP of engineering at Tesla. And we knew we could have 100% smart hardware with over-the-air software upgrades. The printer would get better and better with time. So having a subscription model allows us to future-proof customers from obsolescence, right? Give them increasing capability. When they go into production, they can lock and keep the version of the software because they're validated those parts. You don't want to change that. But the ability to get innovations over time. And so, yes, this is great where, return on invested capital is a non-issue. This is all about OpEx. And it really changes the dynamics of the business.
So operating expenses instead of capital expenses.
Correct.
So this is not a service bureau model as many 3D printing companies have, where they have the equipment, it's on their shop floor, and they make the parts for customers. The customers are getting your machines?
Yeah, but the people that get our machines range from the OEMs that do a lot of product design, like Ford and BMW and others that are public. We have a lot of contract manufacturers that have our printers that work in unison with the OEMs where they can scale up. I think the jury's out about who's going to make the parts. Ford makes their own parts, but a lot of tier providers make some of their own parts too, and this ecosystem's going to evolve. But it all allows people to design parts on the means of production, and then these resins open up, and we have over 50 different resins, and we work with, and 15 of those are from third-party chemical companies. The first ones we've designed, and we established the chemical supply chain with great names like Covestro and Arkema and great companies like that, Sardimer. But we have third-party companies that design resins on our platform, and so it's like an app store for resins.
The people who work for you, I know your background is as a professor. You have some people who came in from Tesla, but the people who work for you, what kind of mix is there? Where do they come from? Do you have conventional auto people as well, or is it mostly the tech community?
It's a mix. It's an amazing company. We live at the intersection of hardware, software, material science, and design. And all that comes together. And so with that, we have people that are amazing material scientists, amazing hardware designers, amazing software people, but we have industry stalwarts. Doug Gergel's here on our team, and he's been with Aptiv for like 30 years. So it's nothing like having people who understand the discipline, understand the challenges, and then all of a sudden see a digital future, and we bring all kinds together.
Couple of more questions here. George from Sunnyvale wants to know, have you talked to any of the Formula One racing teams?
We have, and a lot of them use our production partner network. So we have service bureaus that have our printers, and they often go through them.
And Glenn wrote it, and he says, I'm just asking this in jest. If I put your parts on my car, does it increase my carbon footprint? Well, it does. It's carbon.
It's carbon. Yeah. So, but I don't like to say
said it.
Marketing people won't allow me to say it that way.
Yeah.
Look, it's going to lower your carbon footprint because the parts are lighter, right? From that kind of point of view. And so performance, high-strength, lightweight materials. Our epoxy material actually bonds with carbon fiber prepreg. So one of our customers, who's really in the automotive high-performance industry, is great with carbon fiber prepreg. And a lot of times you want to wrap a fabric of carbon fiber on a lattice and then bake that as one unit. And that chemistry is the same chemistry on a carbon fiber prepreg and becomes some amazing parts.
So 2 quick questions. You and the company, how do you go from being a professor to the CEO of a startup in the Valley?
It's not for the faint of heart. It's great when you have great mentors like Alan Mulally and Ellen Coleman and great teammates at the company. But as a faculty member, there's some similarities with startups, right? You're creating a new future. People think of a new vision. It's tech. It's deep tech, and so that's fun. The challenge is as a CEO, and Alan, it's great to call Alan and, almost cry on his shoulder, right? But look, when I walk in the parking lot, all I see are mortgage payments, car payments. People left great companies. They come work for your company. if that doesn't put a pit in your stomach, I don't know what will. There's nothing like that in academia, right? So there's a range of things, but we have an amazing team. This is creating a whole new category. It's fun to, if you're a polymer guy, it doesn't get any better than this.
And last question about the company, Carbon. Closely held, or are you going to do an IPO?
So it's a privately held company. We have some of the best investors in history with Sequoia, Silver Lake, Google Ventures. Now the Madrone Capital, the Walmart family came in, Temasek, we got Fidelity, just amazing investors. And there's a lot of opportunity for us going forward. And we're right now keeping our head down. We raised a lot of money. We've got a lot of cash. We've got an amazing team. We're focused on building a great business, making sure our customers are successful. And when you do all those things, you'll have lots of options.
Dr. Joseph DeSimone, thank you so much for coming on. This is a fascinating story.
Thank you very much.
Really good, really good. Okay, we're going to take a quick break right now. We're going to give a shout out to our good friends at Bridgestone and DIAMTS. And we'll be back with Mike O'Brien from Hyundai in just a moment.
Whether they're electric, autonomous, or connected, tomorrow's cars must be developed quickly with the highest precision, and they have to be lightweight. DIAMTS can provide what you need, from advanced manufacturing machinery to lightweight components. Learn more at our website at www.d-iamts.com or visit our showroom right next to Metro Airport in Detroit.
It's a good story. All right, we're back talking all things automotive, and now we've done a quick guest change, like a quick die change, although we did it with guests here. We've got Mike O'Brien, head of product planning for Hyundai Motor America. I think I got that right. Vice president.
It's great to be here today.
Yeah, great to have you back. Gary,
One of my favorite guests.
yeah.
Well, let's hope I keep up the good work.
So, all right, so as I mentioned at the top of the show, we were out at your tech center in Superior Township, Michigan, and we saw things we can't talk about. But you guys are making a big play in terms of developing powertrains, which I didn't realize that you guys hadn't been developing for as long as the company's existed. Can you talk about that a little bit?
Well, most people don't realize that we've been working on hydrogen fuel cells since 1998. And our company certainly had some ups and some downs during that period. But one thing I could tell you for sure that we've consistently been investing in hydrogen since 1998 when we began on that project. And keep in mind, nowhere did we have to work in the hydrogen sphere. We were considered a small volume manufacturer by the state of California up through 2018. So we had no requirement to build zero emission vehicles by regulation. And so we did it because our executive management and our company decided it was important to invest in the environment and invest in zero emission solutions and to find ways to really make an outstanding product that would deliver what customers want and offer a zero emission powertrain alternative.
But you still make lots of internal combustion engines, which, I mean, you're also advancing.
We do, and we introduced a really, really interesting technology today that it's just very gratifying to be part of our engineering team. So we introduced something today where it's a world's first. It's called continuously variable valve duration. So we've, for a number of years now, there's been various variable valve timing mechanisms out there. It generally changes the timing of the intake or exhaust cam or how they're phased together. But in this case, we could actually change dynamically how long the valve is open and therefore how long it's closed. And so you could change the effective compression ratio. You could change the effective stroke of the engine through a very, very simple, it's one of those incredibly elegant engineering solutions, but a very elegant solution that allows us to do that in a very durable and effective way. It's very cost effective as well. It doesn't add a lot of weight or mass to the vehicle. And it's a simple mechanism, but yet does it extremely well.
At the end of the day, what does the consumer notice?
What the consumer notices, they notice a much wider range. So this engine produces its maximum torque. It's a 1.6 engine that will debut on our all-new Sonata that will be shipping by the end of this month. It has a completely flat torque curve. It develops maximum torque at 1,500 RPM. So it's ideally matched to a traditional automatic transmission torque converter. So you get really, really outstanding drivability, but also maximizes power, and it maximizes efficiency, and it does a much better job with emissions. So it could basically dither between an Atkinson and Miller cycle based on changing the valve opening period. And it does both intake and exhaust separately.
And you described it as simple, but when they explained it, I felt like it's like when I listened to Stephen Hawking explain how the universe works. As he's explaining it, I think I'm following along, and as soon as he stops explaining it, I don't understand anything of what he talked about. And that was like the mechanism by which this works. You're right, it's a very elegant solution to be able to package it in essentially the camshaft, really. But
basically, it looks like a camshaft, but it's essentially a Rubik's Cube.
Yeah.
When you take it apart, there's all these little parts that slip together, but it's very simple when you put it together.
Well, there have been people talking about doing this electronically, and you guys decided that that wasn't the way to do it.
Well, it really came down to the energy. So if you remember our engineering explanation, or Dr. Ha, that the amount of electrical energy is required to have an electrically solenoid operated valve is very, very high. And then plus there's issues with durability as well. So it's really coming down to the point where it takes energy to displace a valve spring. So how do you minimize the amount of energy to operate the valve train system and at the same time do it efficiently over a long period of time, a durable system?
Mike, you guys introduced today a whole new generation of piston engines that incorporates this technology. Is this the last clean sheet engine that Hyundai would do, or do you think there's more to come?
I think there'll be a little more to come. It's interesting that you bring up one of the most interesting questions among RRD. When you think about our one facility in Namyang, which is outside of Seoul, we have over 10,000 technical specialists. Most of them are engineers in our campus. And of course, the debate's always, when do we start transitioning more of our combustion engineers over to electrification? And how do we transition our workforce over to that, and what's going to be the last generation of combustion engines? But I think looking out in the future, when you think about the current standards we face, we're looking at as a U.S. fleet 54.5 by 2025, and the only way that can be achieved is through some sort of electrification on top of combustion. It can't be done with pure combustion. There's no pathway to that now. So you're going to see a combination of electrification solutions that you saw today, and you're going to see that mated with better combustion solutions. So the combination of those two will deliver these outstanding levels of efficiency that we still allow customers to have vehicles that can be fueled at a local station, but yet deliver fuel economy numbers that allow us to march toward the 2025 goal.
Okay. Does the word hybrid mean anything to consumers anymore because they've been out for so many years, or is it just a matter of this gets me better fuel economy, this gets me more power with the same fuel economy, et cetera? I mean, has it become so much a part of the background that hybridization just is, as opposed to being something special?
Inside the industry, I would say yes, but outside the industry, I think we have to do a better job in terms of pivoting. So when customers hear these terms, it creates a sense of anxiety or concern with some. But when you think about it, if you go back a dozen years, you didn't mind walking into a new car store and saying, gee, I have to decide whether to get the V6 or the four-cylinder. They were both considered great options. One maybe had better fuel economy, the other had better power, but you never thought about one being more or less difficult to work on, or one being more or less durable. But when you say hybrid, there's some customers that still wonder, well, is that really going to work for me? And so I think as manufacturers and as marketers, we have to think more about hybrid just being is another way to move your car down the road. It still uses a gas pump. There's really no reason for us to market them as anything more than an extremely high efficiency choice that customers can make among the choices we already make that take gasoline to operate them.
But to talk about choices, you mentioned that California considered you to be a small manufacturer, yet you have hybrids, you have plug-in hybrids, you have a full EV, and you have the Nexo fuel cell vehicle. I mean, I don't know that there's another OEM out there that has the breadth.
Well, remember, this is a regulatory term based on how they classify.
Right, but I'm just saying that I mean, so bigger companies don't have what you guys have. So what I'm wondering is, in a way, you're sort of spreading your bets, right, in terms of the different technologies. Do you see an end game in terms of what will be powering vehicles? And will this end game happen within our lifetimes? I mean, it's
For a moment, we could look back and then look forward. So if you go back to the 70s, early 70s, our motor culture was gasoline, and then commercial vehicles, over-the-road vehicles, were diesel. And there weren't really any diesel personal use vehicles at that time. And then, of course, there were a few vehicles coming from Europe that would run on diesel. And at that time, you can only buy diesel fuel on the freeway. You have to go out to a highway overpass to a truck stop to find diesel fuel. But as those vehicles became more and more prevalent, cars coming from Europe and then later cars coming from the US makers, now infrastructure started building up in the cities, so fuel stations started offering diesel in the cities. But that wasn't the case back in the early 70s. You had to go out to a freeway on-ramp to find diesel fuel. And so now, if you look forward, you can also think of a time where we're struggling today with getting more hydrogen fuel cell stations available for our customers so they're more confident in their choice to buy one. Of course, we started with personal use vehicles. On the other hand, and they're buying 3 or 4 kilograms of hydrogen typically. But if you're an over-the-road trucker driving a Class 8 truck that's 80,000 pounds, you're going to buy 150 kilograms of hydrogen. So if we start thinking about commercial vehicles with hydrogen, now these fuel station operators are going to say, gee, I can make good money from the day I open up with a few vehicles rather than having to fuel a lot of small vehicles. I could fuel a few big vehicles. So we're focusing on what hydrogen does best and what battery electric vehicles do best. Battery electric vehicles are really ideally suited for personal use where they're smaller class vehicles and the battery capacity and charge time and power performance and so forth match the vehicle class. But when you think about over-the-road vehicles and you're thinking about pulling 80,000 pounds for 500 miles, hydrogen is frankly ideally suited. The powertrain size versus this horsepower delivery is virtually the same as gasoline or diesel. The energy storage size relative to the range and power performance and payload capability is the same as gasoline or diesel. So you can think of a same Class 8 tractor trailer arrangement and it could easily run with a hydrogen powertrain and deliver the same kinds of things that those trucking companies are looking for today. So we see a culture where hydrogen could be very, very valuable for commercial vehicles and also work in personal use cases where the customers wish, and battery electric vehicles being a good choice for smaller personal use vehicles. The bigger story with hydrogen, though, is the idea of hydrogen society, which I know sounds far out and it sounds like a science fiction movie, but when you think about it, when we build a power generation station for a city like the city of Detroit, we have to capitalize that for that one day a year in August when everybody's got their air conditioner running. And for the rest of the year, it's running under capacity, which isn't the best, most efficient way to produce energy. On the other side, we're creating all this solar and wind energy. We're capturing that. But the problem is the wind doesn't blow when I'm watching TV at night. And the lights, the sun isn't out necessarily when I'm at home running my furnace and I'm watching my TV show. And so what do you do with all that energy that's being generated, whether it's solar or wind? What do you do with it when it's more than what the grid needs? And so the question is, how do you efficiently store it? And hydrogen is probably one of the most perfect ways to carry that energy forever. So you can easily convert that energy into hydrogen, store it for as long as you want. You could sell it and move it and have it for whenever you need it, rather than having to build excess capacity in order to be capacitized for that one day a year.
Okay, who does, I mean, turning electricity into hydrogen, I mean, you just say it, it just rolls off the tongue. I mean, who does that and how is it done?
Well, we do it every day right now. It's the electrolysis. So there's a number of, just like when the EV dilemma of how do you make electricity 100% green? Well, it's just a matter of choices in terms of capacity and cost. And the same thing's true with hydrogen. We can make hydrogen in very many different ways. Some have carbon, some have more carbon, some have less, some have none. And electrolysis merely requires electricity and water. So you have all this excess electricity, whether it's solar or wind. We use a little bit of it and some water, and we can store it permanently for as long as we want. We could sell it and move it. So you can imagine a whole hydrogen society now that could be 100% renewable and 100% zero carbon.
So last week at a commercial truck show, and I had no idea that Hyundai had anything to do with commercial trucks. I mean, when I saw the release, I contacted people in Irvine saying, trucks? And it was a hydrogen-powered vehicle.
Class 8 truck.
So is this something that Hyundai does as well?
We've been in the heavy truck business for decades, so we're a very big maker of heavy vehicles. We are not in the U.S. market currently.
With semi-trailers, you are.
Yes, we are. We are with semi-trailers. So TransLead is a Hyundai Group company, and those I think we're the #1 market share over-the-road Class 8 trailer manufacturer now for the U.S. market. So I think we're #1. I think Great Dane and Utility, I think they're up there as well. So and that's been a very recent thing. We've come very big very quickly in that area. So we're already have these trucks in operation in Switzerland right now. The truck that you saw in Atlanta. So we're already.
In fact, we got a picture of it up here. The Neptune, is that the one you're talking about? Very Art Deco kind of styling to it. Streamliner, 30 Streamliner.
I guess, yes.
Mm-hmm. Hey, we got a lot more to ask you about. We've got questions coming in from the audience, but we got to take a quick commercial break. We're going to give a good shout out right now to our friends at Lear and Borg-Warner.
Lear Connexus offers a parental controls application with geofencing that sends notifications regarding driving behavior and location, including curfew alerts, acceleration alerts, and speed alerts. All delivered to a smartphone application that includes vehicle location, driver notifications, and a report card of driving history, including notifications when predefined geographic boundaries are crossed. For more information, visit Lear.com.
The world is changing at an ever-increasing pace. No matter what the mode of transportation, there is always the need for an efficient propulsion system. And that's exactly what Borg-Warner has been doing since the earliest days of the automotive industry. We create innovative mobility technologies that reduce energy consumption and emissions while improving performance. Our proven track record has made us an industry leader in forward-looking propulsion solutions for combustion, hybrid, and electric vehicles.
All right, we're back on Autoline After Hours, talking with Mike O'Brien, the Vice President in charge of product planning at Hyundai Motor America. I had to take a breath in between to be able to finish that. Mike, we got a question here from another Mike from Ontario who says he's got a couple of Hyundais. He's wondering about GDI, gasoline direct injection, of carbon getting built up on the valves. Since, the air-fuel mixture isn't going over the valves, carbon can build up on them. We've heard, not necessarily involving Hyundais, but other companies having real issues with this, with GDI.
I've heard that as well. I am not familiar with any issues we have. I do know that we had some complaints with customers that had light-colored vehicles, that there's a certain amount of sooting that occurs at the exhaust outlet around the bumper cover area in the rear. But I have not heard of any engine problems related to particle buildup on the backsides of valves for us.
How did you guys handle lubrication of the valves? Because one of the ways to lube the valve stems is just to have gasoline go across them, and it was even better when the lead was in the gasoline.
Well, in the old days, they used things like zinc in the oil, which they don't do any longer for a number of reasons. So when you're thinking about older vehicles, they had different technologies. There was usually additives in the oils. But now it's all about material technology. So it's material technology in terms of not only the valve material, but the valve guide material that minimizes the need for lubrication in valve stems, for example.
Gotcha. Okay, we got another question here, but Gary, it goes to you.
Oh, okay.
Whip Good wants to know, are you wearing a Casio G-Shock watch?
Yes, I am. And it's also radio controlled. So when we changed our clocks back,
You didn't have to touch
not
it.
to touch it. And it's solar powered to boot, since I'm lazy and don't want to have to change batteries. So
I'm all for that.
I'm sure you are.
So we just showed today, we showed our new Sonata Hybrid. And one of the things we showed was a
I don't think you can talk about that,
205-watt
can you?
solar panel.
Yeah.
Talk about that.
Yeah.
So-
Well, you guys have announced this earlier too, right? That you're going to put a solar panel on
What
the
does
roof
the
of
solar
car.
panel control? What does it charge?
Well, it's the first time where it actually charges the hybrid battery as well as the auxiliary battery. So, for example, if I'm picnicking, I could run all the vehicle electronics without the engine running. More importantly, it adds about 3 miles of range, of all electric range of the vehicle, over the course of one sunny day. So just by harnessing the power of the sun and leaving your car outside, which you do anyway.
So was it Mazda or someone had a small solar panel that they
Yeah,
were
Mazda
using?
did years ago.
Yeah, Prius does right now, but it only operates a little ventilation fan.
Yeah,
And that's all
that was all
Mazda
the
did.
Mazda thing did.
Right.
Yeah, so it didn't really add any motive power to the vehicle.
But this does,
Yeah.
what you guys are doing.
Dare I ask, what's it going to cost?
No, I
You,
can't.
you can't announce that
Sorry,
yet.
we'll announce that a little bit later.
Okay.
But very soon.
Okay.
Okay, so if you have this roof panel, I mean, you take the car to the car wash, is there a problem?
No. So it's a typical, well, look at the roof of a house that has solar on it. It rains every day.
We live around here, come on, it's not a whole lot of those things around here.
Well, yeah, in some parts of the world where there's quite a few of them. And yeah, there's no real weather.
Here's a picture of the Sonata with the solar panel on it.
Yes,
It looks like two solar panels, actually, in that picture.
yeah, it's one. There's
And,
one
and so
red.
you said it's what, 205 watts?
205 watts.
So that's
Again, on
maybe
a
2
sunny day-
kilowatt hours.
Yeah. So on a typical sunny day, it's about 3 miles of range you get out of it.
Yeah. That's pretty cool.
So we'd get like 200 feet here in Michigan?
Well, if you were in the upper part of Finland where the sun never goes down in the winter, I
true.
guess you get a lot more.
Yeah.
Yeah.
So-
Now, in current electric vehicles, you've got the Kona EV. It's been out there for a while. What have you learned from that, and where do you go from there? And also, you're in California. There have been some rolling blackouts there. Have you had any issues from customers there who have EVs on not being able to charge them because they don't have power?
The biggest issue we've run into is just not enough of them. So, we frankly underestimated market demand for the product, so we're increasing capacity right now to have more of them. We're very fortunate the car's been very well reviewed. What we've learned is that, one, of course, we all know customers want SUVs, and so we're very lucky to have a SUV EV with the Kona. But two, we found out that once the range starts getting up to a number that's close to what you get with a gasoline-powered vehicle, you get a whole lot more folks considering that product. And so with an EPA range of 258, and when you look at the forums, the owners of these vehicles are saying they routinely are getting over 300. Now we're in the area where it's starting to match what you typically get out of a gasoline vehicle, and so the range is no longer a real debate item. And so now, hopefully, we'll start turning the debate back to where we should be, which is efficiency. And so, really, in the end of the day, until we have zero carbon electricity across our country, we have to start thinking about efficiency. And there's a big focus in our work to make sure that our EV products deliver a great efficiency number.
And that other question, I mean, it sounded out of left field, but there have been a number of blackouts in California. It's the biggest EV state in the country. Have you learned things from what people are doing in areas where they may not have power for a day or so, how they're charging their vehicle, where they're going? Because people are resourceful and they find interesting ways. So I've kind of found that fascinating, but I haven't heard anybody really talk about
I think
what's happening.
the rolling blackouts have been so short and so limited in terms of coverage that it's not been a factor that I've heard about for us. Of course, one of our competitors has far more vehicles in circulation, so maybe they've seen some of it, but we have not seen it.
There's another important point. Gasoline pumps run on electricity, and when the power's out, you can't get gasoline either.
Yeah.
So the new Sonata is going to be coming out, and you mentioned in passing that, SUVs are very important to the market now. But you guys decided to do another Sonata, and it looks great. I've driven it, drives great. Why did you do that car?
Well, first, it's a 1.2 million market today. So, we always like to talk about
Just in the U.S.
Just in the U.S., just in the 50 United States, it's a 1.2 million market, and there aren't too many product categories that generate that kind of volume. So that's the first thing. And you have to remember the other thing is that there's still millions and millions and millions of satisfied sedan owners out there that not all of them are upset with their sedan product. So you've got all of these returning to market buyers, and some of them like what they have. So there are some advantages that just to a typical customer, they like the security of covered storage. So if you have an SUV, of course, you usually could peek down and see what's stored back there. That some people don't like that so much. Of course, the potential for driving dynamics is always better with an with a sedan product because it's lower and we can generally make them wider. So, vehicle dynamics can be maximized a little bit better. And for some people, maneuverability and parking are very important, and they feel like they can, more easily garage them and park them in tight spaces. So there's going to be a market for them for the foreseeable future, as we can see, and we want to be a part of that market, and we want to grab as much of that share as we can of that market. So we really over-invested in the next Sonata, and we tried to make it, rather than try and raise the height and have more of a command seating position and make it more like an SUV, we decided to focus it more on being a much better sedan. So we focused on vehicle dynamics, we focused on packaging, we focused on design to make it just a really, really striking product with a one-motion roof. Something that's very rarely done in the automotive industry is to make something smaller. Usually with every generation of a new product, it's a little bit bigger, it's a little bit more, everything is more and bigger.
Yeah, just look at an Accord from 20 years ago.
Yeah, and so in our case, we actually pushed the roof down, something you almost never do, but we used technologies like variable durometer foam in the rear seat, so we were able to recover some of that roof height and still deliver class-leading, top of class, as a matter of fact, front headroom and legroom. And we did that with technology. And we also delivered a very strong, emotional coupe-like design by pushing the roof down just a little bit.
Here, I think you might have a sale. Scott in Cleveland wrote in to say, it sounds like he's interested in the Sonata, but he says the 2020 Sonata was supposed to be available to dealers last month. He wants to know when they're going to be in showrooms.
Check your showroom out at the end of this month, the end of November, you'll be able to find them.
Okay, and he also mentions that Hyundai trucks, he's talking about the big trucks, were available in the U.S. for some time. They were they had a deal with Bearing Trucks? I've never heard of Bearing.
So back in around 2000, we did have a short period of time where we were cooperating with another truck manufacturer. So nothing to talk about today, but it would be interesting for us to consider this market again.
Let's see, Nicholas Shank says, what would it take for Hyundai to throw in the towel with fuel cells?
That's a great question. So again, we have to think about the long game. And so being in this market since 1998 and continually developing fuel cell, frankly, it's going to have to be a failure in terms of infrastructure, and we're not even close to that point yet. We're seeing more and more infrastructure. We're seeing companies like Shell and Air Liquide, Air Products, First Element Fuels. More and more people are coming into the game, and I think that's the only missing piece right now for hydrogen is adequate infrastructure for our customers. So we have a very clear trajectory for cost reduction. You think about R&D in three phases. First, we have to develop the technology, and of course that was done during the Apollo mission period when fuel cells were first developed. So that was handled. And then how do you make it work in a mobile environment in a vehicle? And of course we've now made that happen. And the final stage of R&D is now how do we manage cost? And now we have a very clear trajectory, as we learned earlier today, a very clear trajectory to manage the remaining items that are more costly than they should be. And we have a clear pathway towards making those items lower in cost in a way that will approach parity with combustion engine products in the future. So it's really going to come down to making sure that we do everything we can to support infrastructure development.
So for those who weren't there today, it was at 2025 you thought that you'd be able to meet battery electric vehicle costs and it would be,
yes,
parity. Okay, so here's my question. I was so impressed with all of the good things about fuel cells. I'm wondering, are you going to have a hockey stick-like acceptance of this technology? And what does that do to all the investment you have in the other stuff?
Well, again, I really believe, just like today on the roads today, we see big vehicles running on diesel fuel. We see small vehicles that are primarily gasoline vehicles. I could easily imagine a zero carbon mobility future where we have hydrogen for heavy class vehicles and battery electric for lighter class vehicles.
So I'm not going to be able to get a hydrogen-powered Sonata at 2030 or something?
I didn't say we could offer hydrogen on any vehicle, but I would say it's ideally suited for heavy vehicles. So as you can see with Nexo, so that's basically in the same weight category as a Sonata.
Mm-hmm.
Hey, I think we should wrap this up, but we've got a phone call from Dale Leonard. Carmen, let's bring that in.
Greetings. This is Dale Leonard out of Cleveland, Ohio. No question, just couldn't miss my weekly call-in to say hello to everybody, and great show as always. Take care. Talk to you next week. Bye-bye.
Real good. Thanks for that, Dale. Probably a great way to wrap up the show here. But Michael Bryan, thanks for coming back. It's always good to have you on the show here.
Thanks for allowing me to be with you this afternoon.
Yeah. And well, we're going to have you back because, as Gary mentioned, you gave out a bunch of information today that's under embargo. So when the embargo's off, we need to get you guys back here.
I'll look forward to it.
Real good. Jeff Gilbert, WWJ News Radio 950. Thank you for coming on here today.
Thank you.
Really good having you. And Gary, we'll just keep on doing
Okay.
it. Real
Great.
good. We'll wrap it up.
Autoline After Hours is brought to you by Bridgestone Tires, your journey, our passion. Lear, a global leader in automotive seating and electrical systems. Borg Warner, propulsion solutions that support a clean, energy-efficient world. And by DIA MTS, for advanced manufacturing machinery and lightweight components.
Visit our website, Autoline.tv, where you can watch us live Thursday afternoons. Get your daily fix with Autoline Daily and in-depth analysis and interviews with Autoline This Week. There's all that and much more at Autoline.tv.